Students, now we start to introduce the basic group in the amplifier. In this section, we will talk about the following parts. First, we introduce the actual circuit of 3 configuration amplifiers. We will introduce tertiary tube, the performance of 3 configurations of amplifier core components. On this basis, we will introduce the situation of the improved amplifier. Finally, we will talk about the 3 basic configurations using the field effect tube as the core component of the amplifier. Performance of cascade common drain amplifier. In the basic circuit of the amplifier, transistors can be connected in different ways. Take the critical transistor as an example. Both base and emitter can be used as amplifier input. Both the collector and the emitter can be used as amplifier circuits output. They are called the common emitters we introduced earlier. 3 basic configuration circuits of common motor and common base. Various actual amplifier circuits are based on these 3 configuration circuits, then involved. So, we learned the performance characteristics of the 3 basic configuration amplifier is the basis for understanding the performance of various amplifiers. Next, let's introduce 3 kinds of the actual circuit diagram of the basic amplifier. The circuit on the right side is the common emitter. Actual circuit of the amplifier circuit. We use some methods from the actual circuit to draw the DC path in the actual circuit separately, and the communication channels. DC paths can be used for analyze static operating point of the amplifier circuit. The AC paths can be used to analyze this configuration. Amplifier circuit performance characteristics. So, how to put an actual circuit? Draw its DC path and AC path separately. We follow the method below. For the DC path, we treat all coupling capacitors as open circuits and make AC signal source be 0. Zeroing the AC signal source means that the voltage source is considered a short circuit. Current source regarded as open circuit. Now, we take the actual circuit, strip its DC path. First, consider all coupling capacitors as open circuits. This way we get a VCC. Through the upper and lower bias resistors, a voltage divider formed by the circuit is among them. The emitter is also connected to the feedback resistor RE, as shown in the DC path. 0 voltage source VCC. 0 setting is to connect VCC to ground. This will transform the circuit a bit. We can get the communication channel. Let's take a look. Starting from the signal source, Vs and the signal source internal resistance Rs directly connected to the base of the triode, and the bias resistor RB1 in the base of the transistor. Since VCC is set to 0, RB1 is connected to GND, and B2 is also connected to GND. So at the base is equivalent to RB1 parallel RB2. At the output, its collector is connected with a resistor RC due to VCC being set to 0. So, RC is directly connected to the ground. The load resistance RL is shorted due to the coupling capacitance. RL is also directly connected to the ground. At the same time, it is directly connected to the collector of the triode. For the emitter, the coupling capacitance of the emitter short circuits the feedback resistor R1, so the emitter is directly connected to the GND. We can see through the communication channel. The 3 electrode bases of the triode are used to input, collector as output, and the emitter is used as the common terminal of input and output. So, we'll call it a common emitter amplifier circuit. It can be seen that the judgment of the configuration is mainly judged through the communication channel. Let's take a look at the common base configuration. Common base configuration, its input is the emitter, its output is the collector, capacitively coupled to the ground at the base, so it is a common base configuration. We use the same method to draw it separately, DC pass and AC pass. When drawing the DC pass first, we treat all coupling capacitors as open circuits. Start from VCC. We can get a VCC through RB1 and RB2, base offset setting. VCC is connected to the collector through RC, which is the output of amplifier circuit. The emitter can be seen through the resistor RE to ground, DC pass of the actual circuit with common base configuration. It is also voltage divider bias circuit. Now let's look at the drawing method of its communication paths. When drawing the AC path, treat all the capacitors as short circuits. Then the signal source Vs and Rs connect directly to the input emitter. The load resistor RL is directly connected to the output. The base part is directly connected to the GND through the coupling capacitor CB. The second point sets VCC to 0. Zeroing VCC is equivalent to shorting VCC to ground. By finish the circuit, we can get the communication paths of common base configuration, as shown on the right. Here, we see that the input terminals RE are connected in parallel, with amplifier input, to bias resistors RB1 and RB2, because they are connected to the ground at both ends in the communication channel. RB1 and RB2 do not exist. Its base is directly short circuit to the ground. The collector of the output terminal is connected to the RC to the ground and the load resistance RL to ground. We can treat the resistance RC and RL of the output as a resistor. We also can write it as RL. Obviously, RL is equivalent to the parallel value of two resistors. Let's look at the common base configuration. Common base configuration actual circuits, DC pass and AC pass. DC pass is relatively simple. Disconnect the capacitor, we can get its DC pass. Its AC pass sees the capacitor as a short circuit. The collector is directly connected to the ground. Arrange the circuit to get the following AC pass. It can be seen in the circuit. Its collector is a part of the input circuit. It is also a part of the output circuit. So, it is a common collector configuration. Through the above analysis of the three circuits, we can see the different configurations of the amplifier, which focused on the communication channel. The DC pass is the bias circuit. They have nothing to do with configuration. This conclusion tells us, is the composition of an actual amplifier circuit correct? It depends on whether the DC and the AC pass its draw are correct. The AC pass determines the configuration of the amplifier. If we replace MOS transistors with crystal transistors, then these three configuration circuits will be transformed into common source, common gate, common drain FET amplifiers in three configurations. Okay, this is the end of this class. Please finish the test questions in this section according to what you have learned today.